Hello everybody, welcome to the last video in Unit 10, 10.7, where we're going to be doing a mix of solving equations, graphing logs, and graphing exponents and whatnot, just to kind of get you to figure out the best way to solve each one. And so let's start here with number 1, and it asks you to solve for x. Here, in my opinion, is the fastest way to do the problem. You do have an exponential equation, which means you could apply logs, but I would always consider asking yourself, can I change the bases first to be the same? I can write this side as 2 to the first. Can I write 8 also as a base of 2? Yes, I can. 2 to the third. And then I still have the 1 minus 2x in that exponent. So it would be 2 to the third times 1 minus 2x equals 2 to the first. And now, because the bases are the same, I know that the exponents have to be equal. So you could say 3 times 1 minus 2x equals 1. Solve from there. You would have 3 minus 6x equals 1. Negative 6x would equal negative 2. So if I divide both sides by negative 6, you get 2/6, or better, 1/3. So if you didn't see that, you absolutely could take the ln of both sides and solve from there. However, my suggestion would be change the base, because usually that's the faster way to do the problem. Number 2, graph and find the domain, asymptotes, and intercepts of this log function. My suggestion on this is always to consider the parent function first, which the most basic one would be just y equals ln of x. And if you have any kind of log function, there's always 2 points that you always go through. One of them is 1, 0, and the other one is your base, 1. And so in this case, 1, 0, and the base of e, or the base of ln, is e. So the 2 points you start with are 1, 0, and e, 1. And after you consider the parent function, you consider what this graph is actually doing, which is going to the left 2 units and going up 3 units. So if I apply that idea to these 2 points, left 2 in both situations would be negative 1 and would be e minus 2, technically. And then going up 3 units would land you at 3 and land you at 4. E minus 2 is really 0.718, just to help you kind of see where this really is. So if you come over to the graph and graph these points here, negative 1, 3, and 0.718, 4. Your log graph, or anytime you have a logarithm graph, you always have a vertical asymptote. And because I shifted left 2, for the parent function, the vertical asymptote's always on the y-axis, so it would make sense that it's shifting left 2 as well. If I follow the asymptote and connect the points I have, this would be a sketch of my log function. And now that I have the sketch, I can answer the questions. It would like me to find the domain, which in this case would be from negative 2 to infinity. It would like me to find the asymptotes. In this case, we have a vertical asymptote at x equals negative 2. And it also would like you to find the intercepts. Now, it doesn't specify if you'd like to find x or y, so I'm going to find both. And what I'm going to do is focus on how you can do this algebraically. That's one reason this video is important. If you'd like to find the x-intercept algebraically, because we're not quite sure what that is, remember, that is where y equals 0. So in the original equation, you could say 0 equals 3 plus ln of x plus 2. And then you could solve for x. You could move the 3 over and get ln of x plus 2 equals negative 3. Then, because you have a log, you could change that to an exponent, because there's really an e here. E to the negative third equals x plus 2. So x would be, in exact form, e to the negative third minus 2. And so it's okay, if you want to find your x-intercept, to leave it as e to the negative third minus 2, 0. This is technically a decimal, and that decimal would be right here, but it's okay to leave your answer exact just for the sake of time. If you would like to find your y-intercept, on the other hand, that is when x is 0. So in the original equation, which was this, you could plug in y equals 3 plus ln of 0 plus 2. So this one's a little easier. Y would be equal to 3 plus ln of 2. And so if you wanted to keep your answer exact, your y-intercept would be 0, 3 plus ln of 2. If you'd prefer to write this as a decimal, you definitely can, but this answer would be about here on your graph. What I love about the second problem and the third problem being next to each other is I'd like you to notice that the parent function is ln of x. In the next problem, this exponential one, the parent function is y equals e to the x. Now, is there a relationship between ln of x and e of x? Yes, these are inverses. So instead of making a big table, why don't we use what we just did on the last problem? I know that the 2 points for any log function are 1, 0 and e, 1, or 1, 0 and base, 1. But because they're inverses, why don't we say that instead of 1, 0, this time it's going to be 0, 1. Instead of e, 1, my parent function is going to be 1, e. So these are the points I'm starting with this time, because inverses, it's true that x equals y, so you can flip them around. That's the definition of an inverse. And then if you think about what the graph is doing, we're going to the right 3 and we're going down 2. So these points, if I went to the right 3, we would have 3 here and we'd have 4 here. If I went down 2, we'd have 3, -1, and we would have e minus 2, which could really be thought of as 4, subtract this, 0.718. So if I graph these 2 points, it would be at 3, -1, and it would be at 4, almost up to +1. Now also, if you consider inverses, on number 2, in a log function, the asymptote was vertical. So it makes sense here, for the second one, that the asymptote is horizontal. So I'm going to have a horizontal asymptote. So if my horizontal asymptote of the parent started on the x-axis, it would make sense that it would go down 2 units because the function's going down 2. So if I take a look at my exponential function, it's going to get close to the asymptote and then rise exponentially. So my graph would look something like that. And so if I wanted to answer the questions again now that I have my picture, my domain of my exponential function goes all the way from the left to the right. So it's -infinity to +infinity. My asymptote, my horizontal asymptote, would be at y equals -2. And my intercepts, let me just find both again. My x-intercepts would be when y equals 0 into the original equation. So that would be 0 equals e to the x minus 3 minus 2. And if I'd like to get x alone, I'm going to move 2 to the other side. And if I would like to get this exponent down, I have to apply logs on both sides. That's why it's so important to know how to solve a log equation. ln of 2 equals ln of e to the x minus 3 power. I can bring this exponent down in front, and I also recognize that ln and e are inverses, so those cross out. So I have x minus 3 equals ln of 2. So that means that x equals ln of 2 plus 3. So my x-intercept would be ln of 2 plus 3, 0. And again, you can leave that answer exact. If I would like to find my y-intercept, that means that x equals 0 in the original equation. So you'd have y equals e to the 0 minus 3 power minus 2. So y would be equal to e to the -3rd minus 2. And again, you could flip this to 1 over e to the 3rd, or you could leave it like this. I'll flip it this time. So our y-intercept would be 0, 1 over e to the 3rd minus 2. There's a lot of good review in these two problems because you are solving equations within graphing, so I think they were worth our time. Find the domain of the following. Both of these are log equations. So remember, in an earlier video, we said that a log equation, when graphed, looks like this. And so the domain is from 0 to infinity of the parent function, which means that we cannot have negative numbers. X must be bigger than 0. So that means that whatever's inside this log, 3 minus 4x, must be bigger than 0 in order to make the log true. So if I solve this, and I subtract the 3 over, and then I divide by -4, remember when you divide by a negative, the inequality flips. So you get the inequality x is less than 3/4. And if I wrote that in interval notation, that would mean that my domain would be from -infinity to 3/4, both not included. For the second example, it would mean that this value would have to be bigger than 0. So x minus 1 over x plus 2 must be bigger than 0 to be true. Now, here's the reason we do cumulative testing, because this has been all over some of your last tests and it comes in handy right now. We can't cross multiply. We need to use the number line to check which intervals work. And our two critical numbers are -2 and +1. This one is never included because it's in the denominator, and this one's not included because we just have a greater than symbol. So if we check all of our intervals here into this, if I plug in -3, that would be a negative on the top and would be a negative on the bottom, which is a positive. So this makes it bigger than 0, so that works. If I plug in 0 in here, you get a negative on the top and a positive on the bottom, which makes a negative. Nope. If I plug 2 in from this interval, that would be positive on top and positive on bottom, so we get positive. So that's why knowing, this is why the cumulative review is so important, because of something like right now. The answer in interval notation would be -infinity to -2, union 1 to infinity. This next example, we've practiced these a decent amount in class, so I'd like you to pause the video and try this on your own. If you're trying to expand, remember you're trying to get multiple logarithms. And I would suggest thinking about where you're multiplying and where you're dividing. So please pause now, and I'll come back with my answer. All right, what I did was I noticed that on the top we had x times this radical, and when you multiply within an argument of a single log, that's the same as 2 logs being added. And then the x plus 2 cubed on the bottom is the same as a log being subtracted. So I wrote that out as 3 separate logs first. I then rewrote this as something to the 1/2, brought down both powers, and this was my final answer in the box. Feel free to pause, feel free to copy this, and feel free to ask questions about this the next day in class. This problem is interesting because we haven't seen anything quite like it, but I think it's a good thinking question. It's tempting to cross out 5 and log base 5, but we have this darn plus sign in the way. So this is 5 to both of these powers. So I'd like you to think about, if I told you, if you have 5 to the 2 plus 4, that is really the same as 5 to the second times 5 to the fourth, right? If you started with this problem, 5 to the second times 5 to the fourth is really 5 to the 2 plus 4. So what if we wrote this as 5 to the log base 5 of 6 times 5 to the log base 5 of 7. In this case, now that we don't have this plus sign here anymore, 5 and log base 5 are inverses, so you're left with just 6 because that exponent technically comes down, and 5 and log base 5 are inverses again, so you're left with 7, so the final answer would be 42. Here's another way to think about it. At the beginning of the problem, you have 2 separate logs. You could condense this to be 1 log. If you have 2 logs being added with the same base, that is the same as the 2 logs with the arguments being multiplied. So it's 5 to the log base 5 of 42. So 5 and log base 5 are inverses, so here my answer is 42 again. This last equation, we have 2 separate logs being subtracted. So what we could do to make our lives easier is to make it into 1 log, and if we're subtracting, the arguments are dividing. So we could write our answer like this. Now, if I have a log equation, again, it's good to go from a log and use the inverse of an exponent. So let's change this into an exponential equation. When you see a log, you can assume the base is 10. So the base to the exponent of 1 has to equal 7 minus x over 3x plus 2. So here's where I'd like to pause the video, have you think of this as cross multiplication, and please solve. I'll come back with my answer in just a minute. So my final answer was -13 over 31, which is okay, because if I plugged this back into both cases originally, I got positive values here, so there's no extraneous. The answer is just a fraction, which is perfectly okay.